Hello folks, we come to the exercise 9.3 part 6 video, and we are taking up the 17th question, and in the 17th question they say that the 4th term, 10th term and the 16th term of a GP are x, y and z. You need to show that x, y and z are in GP. Earlier we have seen in one of the earlier problems that whenever three quantities are being asked in a GP, it's always better to get the square. We used to do, if x, y, z is in a GP, means it's as good as showing y squared equal to xz. Somehow if we are able to show that y squared equal to xz, then your work is done. So right away we can start. We are given A4, A10, A16. So let our GP have the first term A and ratio R. Let A comma R be the first term and common ratio of this GP. Okay, so here A4 is 6, 10th term is y and 16th term is z, which by formula an is AR raised to n minus 1. By that idea, it's AR cube becoming x, AR raised to 9 becoming y, AR raised to 15 becoming z. Right away we will try to show y squared equal to xz. So for that, let's consider y squared. Consider y squared, which is AR raised to 9 whole square. When we square it, it is a squared into r raised to 9 the whole squared, which is a squared into r raised to 18. Also let's consider yz, or sorry, xz. X for us, it is AR cube, and z for us, it is AR raised to 15. So let's club the terms together. A into a squared, r raised to 3 into r raised to 15, a raised to m into a raised to n is a raised to m plus n. So like that, that will become r raised to 18. Net effect, we have y squared equal to xz. Therefore, y squared equal to xz, and therefore x comma y comma z are in a GP. That is the question. In the 18th question, they give us a sequence with so many terms, 8, 88, 888, and they ask us to find the sum. So we have to find the sum. Now the problem with this sequence is, that means what we are supposed to find, we have to find, therefore Sn is 8 plus 88 plus 888 and so on. But the problem over here is till n terms, Sn, so till n terms. These numbers, they are neither an AP nor a GP. So we have to use a different approach by which we will be able to get the sum. So let us see now. Anyhow, it's clear to us that 8 is common. So let's take the 8 out. So what do we get? We'll get 1, 11, 1, 1, 1 and so on. As a tool to solve this, let's multiply and divide by 9. So that we are not changing the value, but this will be useful to us. We have multiplied and divided by 9. This is not changing the value, but this 9 we are taking it inside the bracket. So what will happen? 9 plus 99, 11 into 9, 99, 111 into 9, 999 and so on. How does this help us? 9 could be called as 10 minus 1. 99 could be called as 100 minus 1. 999 could be called as 1000 minus 1 and so on. The last term, nth term, will be 10 raised to n minus 1. In the next step, let's take all the powers of 10s together. 10 squared, 10 cube and so on, 10 raised to n. And 1 minus 1 minus 1, all that will subtract together and give you minus n. Minus 1, minus 1, minus 2. Minus 2, minus 1, minus 3. Like that, when you keep adding, it will come to minus n. So this part of the thing is solved. How about this part? It is a GP. So we have converted the sequence into a GP. Now how is it a GP? It's a GP with A as 10, R as also 10, right? And for a GP we know, therefore the formula is Sn is A into R raised to n minus 1 by R minus 1. So that solves our problem. This part will be 10 into 10 raised to n minus 1 by 10 minus 1, 9 minus n. You can open up the bracket and get the final answer or keep it like that. So this is the sum of that given term. Then we have next question, 19th question, where they give us two progressions. What do they call it? The sum, find the sum of the products of the corresponding. Okay, there are two sequences. These are the two sequences. They ask us to get the product of the sequence, and to that product find out the sum. right? So from this sequence, let's get the product. Product sequence is, that means you're taking the product. 2 into 128 first, 4 into 32 next, 8 into 8 next, 16 into 2 next, 32 into 1 by 2 next. Now, if you carefully see, these are all powers of 2. So like it's 2 into 2 raised to 6, 7. Yeah. This is 2 squared into 2 raised to 5. This is 2 cube into 2 cube. This is 2 raised to 4 into 2 raised to 1. This is 2 raised to 5 into 1 by 2. So let's see what will come. 2 raised to 8, a raised to m into a raised to n is a raised to m plus n. We are adding up the powers and that will become 2 raised to 8. How about this? 2 raised to 7. This is 2 raised to 6, 2 raised to 5. One of the 2's will get cut, 2 raised to 4. So the resulting product sequence, it is actually a GP with first term as 2 raised to 8 and the ratio being 1 by 2. So we can find the sum, we have the formula. So this is a GP, with A as 2 raised to 8 and R as 2 raised to 7 by 2 raised to 8, which is half. So S 5 terms are only there. So it's A into 1 minus R raised to n by 1 minus R. We're using the formula 2 raised to 8 into 1 minus R. R for us is half raised to 5 by 1 minus half. 1 minus half is half, and that too divided by divided by something means multiplication by the reciprocal. So that half will go up and will become 2 raised to 9. So you'll have 1 minus half raised to 5. So what will come? 2 raised to 9